Welcome to H4-3, part 2 of the notes. We're going to start out with an example here. The directions state solve the equations and check the validity of your solutions using parts A through C below. Letter A, solve algebraically using any method of your choice. All right, we've got an equation here. It's the quantity of x plus 1 squared minus 2 equals 7. So we've got a quadratic. We've solved these already this year. The method I'm going to use, I'm just going to undo the equation until I get x by itself. Remember, when you have grouping symbols and your x is inside those grouping symbols, we need to isolate those before we do anything else. That means we're going to add our 2 to each side. And we have the quantity of x plus 1 squared equals 9. Let's undo the square by taking the square root. And remember, when you take the square root of something squared, you're going to end up with the absolute value of whatever's inside. So we have the absolute value of x plus 1 equals 3. Absolute value is talking about the distance from 0, and we know there's two numbers that are 3 units from 0. So x plus 1 either has to equal negative 3, or x plus 1 is going to have to equal positive 3. Those are the two numbers that are 3 units from 0. So when we finish solving it here, we're going to, the value of x should equal negative 4, or the value of x should equal 2. Now, unlike the first video here where we took our values and we plugged them in and checked it algebraically, we're going to check it a little differently here. So part B says check your answers by setting equal to 0 and graphing to find the x-intercepts of the function. So this is our first method for checking or even solving by graphing. Okay, we're going to set it equal to 0, and then we're going to find the x-intercepts. Just recopy your equation. And to get it equal to 0, probably the easiest thing is going to be just to subtract the 7 from each side. That should give you the quantity of x plus 1 squared minus 9 equals 0. And we're just going to take it here, and we're going to change our 0 into a y so that we can graph this function. Remember, though, that when your y is 0, that's referring to the x-intercepts. Right? So when y is 0, we're referring to this line here, the x-axis. All of these points have y-coordinates that are 0. So this, we should be able to graph pretty easily. We've graphed plenty of these already this year. So remember, our locator point is our vertex, and that would be at the point negative 1, negative 9. It's like our h and k values. So we're going to plot that point first. It has standard growth, so we go to the right 1 and up 1 squared. We go to the right 2 and up 2 squared from the locator point. And we'll just reflect those over. The right 3 and up 3 squared, which is 9, that should take us all the way to the x-axis on this one. So we have enough points here that we're just going to go ahead and draw in our parabola. Now this asked us to pay, special attention to our x-intercept, so I'm going to kind of bold those here. The x-intercept on the right is the point 2, 0, and the x-intercept on the left is the point negative 4, 0. Okay, you think about it, that's like your x and your y, your input and your output. So when our outputs are 0, right, when our outputs are 0, the inputs that we have, right, our x is equal to negative 4, and our x is equal to 2. And we'll find those are the same as the answers to our original equation. Okay, so we had two solutions when we solved it algebraically, and we see that we have two solutions on the graph. So it asks here now, where can you find your solution on the graph? Well, if we set it equal to 0 and we graph it, the solution to the equation is going to be the x-intercept, or the x-coordinate of the x-intercept, we should say. And the reason I'm trying to emphasize it's the x-coordinate of the x-intercept is because when you solve it like this, right, we get these points. And what ends up happening a lot of times is students will write down that the solution is -4, 0 or 2, 0. The solution, right, our equation has just an x in it. So when we're solving it here, we're looking for just an x. So the x-coordinates that we get are the solutions to the equation. That's all we're interested in. So x is equal to -4, and x is equal to 2. All right, let's look at a second way here for either solving it by graphing or checking your answer. Letter C states, check your answers by graphing the equation as a system of equations to find the intersection points. So now we're going to graph it as a system, and we're going to find the intersection points. So this is our, I'd say our second method for solving or checking by graphing. So the first one, we got it equal to 0. We graphed it and found the x-intercepts. For this one here, we're going to take it and do like we did in the first video of this section of notes. We're going to take the left side of our equation, and we're going to create a function from that. So I'm going to go ahead here and write down y is equal to the quantity of x plus 1 squared minus 2. So we have a parabola for that part. And then we're going to look at the right side and make a function out of it. That one's just y equals 7. So they're going to ask us to graph these. This one, our locator point, is at -1, -2, and we'll plot that on our graph. It has standard growth, so you can go ahead and graph your parabola there. And then connect your points. And try to be neat about it. I've seen some of your parabolas and yikes, okay? But try to be as neat as you can. Mine's not perfect, but, do your best. It shouldn't zigzag in and out and look like you did it with your feet, okay? Do your best to try to make it accurate as you can. So the second part here, y equals 7, okay? So we've got 7. What is the slope of that, right? So remember, the slope here is 0, because this is like y is equal to 0x plus 7. So our y-intercept here is actually 7. This is just going to be a horizontal line. So we're going to find our y-intercept at 7, and this is just going to be a horizontal line. These are all the points on the coordinate plane that have y-coordinates of 7. And you'll see here, it's asking us to find those intersection points. We have the point 2, 7, and we have the point -4, 7. And I think it's pretty safe to say here, right, since we are checking our answers from the last one here, that we can see our solution here now is going to be the x-coordinate of those intersection points. So let's go ahead and jot that down. Where can you find the solutions to the original equation now? Whoops. So the solutions to the original equation are the x-intercepts of the intersection points. I should say x-coordinates of the intersection points. I'm losing my mind. All right, so the solutions to the equation are the x-coordinates of the intersection points. Smiley. Okay, in this case, again, we had x equals -4 and x equals 2. All right, so let's move on here. I don't want to drag this out. Let's just do one more example. This one says, solve algebraically using any method of your choice. Well, my method of choice on this one here is to undo it again. We have a square root of the quantity of 5x plus 6, and that equals x. And hopefully we all know now that we need to square both sides. That's going to give us a 5x plus 6 is equal to x squared. So this is quadratic. Set it equal to 0. If it's me, I'm going to go ahead here and subtract the 5x and the 6 from each side. That way my x squared remains positive, and that's probably a little bit easier to factor then. So this one should factor into x minus 6 and x plus 1. And when we set it equal to 0 and solve it there, we're going to end up with an answer of x equals 6 and x equals -1. Now, we didn't check the last one algebraically. Okay, I'm going to do that on this one here because there's some things that we're looking at that are going to be important. So when I take this and I plug in my x equals 6, right, we've got 5 times 6 plus 6 under the square root, and we say that equals 6. That should give us the square root of 36, which is 6. So that one's going to check out for us. When we check our x equals -1, we've got 5 times -1 plus 6 should equal -1. Well, that should give us the square root of 1, which is 1, right? And that does not equal -1, so therefore x cannot equal -1. This is an extraneous solution. Now we're just going to practice the two methods for checking by graphing. So letter B says, check your answers by setting equal to 0 and graphing to find the x-intercepts of the function. So same as it was on the last one there. When we get this one equal to 0, we're just going to subtract the x from each side. That's probably going to be the easiest way to do it. I've got 5x plus 6 under my square root, and then I have minus x equals 0. Let's change that 0 to a y, and that'll allow us to graph it as a function. Everything else remains the same there. And we're going to use a graphing calculator for this one because we've not graphed square root functions where we've got a coefficient on our x before. So let's go ahead here. I have a graphing calculator set up here, and let me actually jump in here, and I think I already did this video about 18 times, and so I need to delete out that part. There we go. So I've already typed it in. You can use whatever graphing calculator you have available. If you don't have one, get on the App Store and download a free one and figure out how to use it. There's no excuse for not having a graphing calculator these days, especially when people make them for free for you. All right, so I'm going to graph this here, and you'll see here we've got this nice looking curve. And to transfer this onto our paper here, we just need a couple points here. So let's just take this here and let's look for a few points. I'm going to kind of look at the end point here, which is about, if we look up in the corner up there, looks like it's a little bit less than -1 and a little bit more than 1 on the y. And then we'll take it here, and we've got our y-intercept is just a little less than 2.5. Okay, so you want to write that on your paper probably. And then let's go ahead and put our x-intercept on there, which is 6, right, 0.60. So we'll plot those on our graph. So the first one there, we were a little bit less than -1 on the x and a little bit more than y is 1, so we're about right here. And we were a little less than 2.5 for our y-intercept, and then x-intercept was 60. Plot them on there, and then just do a nice little sketch. Doesn't have to be super accurate, right? It's a sketch. All right, now when we look at that here, right, this one was asking us to look at the x-intercept there, right, and our x-intercept was 6, 0, right, that was our x and our y. And remember, our solution up here was x equals 6. So in answering the question below where it says how many solutions or x-intercepts does this function have, well, it has one solution there because it has one x-intercept. So when you're solving using this method here, right, you're trying to figure out how many x-intercepts it has. If it has just one x-intercept, that means it has just one solution. And if you hadn't figured out already at the top that there was an extraneous solution, this is where you would see it. This is really important here. In fact, I wish I knew this when I was in high school. This is a game changer because you can solve any equation this way. Even if you don't know how to do the work, you can solve it by graphing and finding the x-intercept. Okay, hopefully that sticks with some of you, but we'll see. We'll see. But we'll get lots of practice with it there, and we'll make sure it sticks at some point. All right, let's jump into that second method here for doing it, and we'll do this one real quick because I don't want these notes to drag on any longer. This is about the 6,000th time I've done this video. So we're going to start out here. Check your answers by graphing the equation as a system of equations to find the intersection points. So remember, this is that second method. We're doing it as a system, and we're looking for the intersection points. So the way this one worked, remember, we took our left side, and we're going to make a function out of it. Y is equal to the square root of 5x plus 6. And then we're going to make a function out of the right side, which is y is equal to x. And to graph this, we're probably going to have to use the graphing calculator again, at least for our function on the left there. So let's do that. I'm going to go into my handy dandy graphing calculator here. And I'm just going to alter that there. Now we have our two functions. Y is equal to the square root of 5x plus 6, and y is equal to x. We graph it. And y equals x we can graph on our paper. That one's not going to be a problem, but let's just look at our points for our square root function. So again, it looks like we're just a little less than -1, but this time we're just a little above the x-axis. And then we're going to hit at, looks like a little less than 2.5 on the y. I think it's the same y-intercept. And then our next point, though, is now at the point 6, 6. Okay, so let's go ahead and plot those on our graph. We'll do that one in red. So we said just a little less than -1, a little above the x-axis. We had a little less than 2.5, and then we had the point at 6, 6. Hopefully that's where I'm at there. It looks like it. And there's our square root curve there. Let's do our y equals x, right? Our slope on that one is going to equal 1, and our y-intercept is 0. Good. I did graph the other one correctly. It's always a pain when you get to the end of a video there and you screw up. I don't want to jinx myself here, though. All right, there we go. So we got a point right there. Remember, this is that point 6, 6. It asks us to look for the intersection point. Right, so is there an extraneous solution? Yeah, we already said there was an extraneous solution. I believe that extraneous solution was x equals -1. Right, we'll say that x can't equal -1 in that case. And if you think about it here, right, if this square root function actually had that second half and started going down, it probably would have hit somewhere down there, right? And would have gone down like this way. But we don't have that, so we don't have to worry about it there. But it's always a lot easier to see your extraneous solutions there, like if there are any by graphing. To figure out what they are, you probably want to solve it algebraically. Okay, so what is it? So let's actually jot that down. I haven't jotted that down before, but extraneous solutions, right? So we can see if there are some by graphing. But we can see what they are by solving algebraically. Algebraically. There you go. All right. So the solution to our equation, though, remember again, is just going to be the x-coordinate of the intersection point there. So our solution again, one more time, x equals 6. It's not the 0.66, just this. All right, so I don't want to drag this out any longer than I have to. So we got one more little thing here I want to talk about, and hopefully you're paying attention to it. The last two slides of your notes pages that you're working on right now have a problem in here. Okay, this problem is the rest of your assignment. I am not going to walk through this one in the notes. You're going to do it, and then we're going to discuss it in class. So why don't you help out Gustav's team? This is Gustav's problem here. You're going to read through this here and answer A, B, C, D, and E to the best of your ability, and then we will discuss that in class. If you don't have this problem done, then I know that you didn't really do your notes. Okay, so make sure you do your notes here. That'll help you out, and then we will crank out our assignments in class. Hopefully this helped, and hopefully you're understanding a little bit here, and I look forward to talking about it in class. Thanks for watching.